All right, so our last lesson introduced us to the world of factoring. We did standard greatest common factor factoring strategy, and we also did factoring by grouping. Today we're going to stretch that out a little bit, and we're going to learn something called factoring simple trinomials. Of course, we have to know what a simple trinomial is first. Let's start small, though. Let's do a little bit of a warm-up. Now look on the left-hand side here. We see this expression x plus 8 multiplied by x plus 3. And we're going to expand and simplify. So we're going to go way back to 5.1 for the day, or for now. So let's go through here. So what I need to do is I need to FOIL out these binomials. So we end up with x times x, which is x squared. And then we get x times 3, so that's plus 3x. And then we have 8 times x, 8x. And then 8 times 3, which is 24. And then we simplify it by collecting our like terms. The only like terms we have here are 3x and 8x. So we end up with x squared plus 11x plus 24. Okay, let's do it again on the other side over here. On this one, we're going to FOIL it out. So we have b times b, that's going to be b squared. And then we have b times negative 3, so that's minus 3b. And then 4 times b, so that's plus 4b. And then finally, 4 times negative 3, which is minus 12. Again, we're going to collect our like terms. The only like terms we have are the negative 3b and the positive 4b. So negative 3 plus 4, that gives us a 1. So b squared plus b minus 12. So this is what we learned a couple days ago. And you're like, why are you showing us this right now? Well, let's see where this is actually going with this. First of all, let's talk about what a trinomial is. We know a trinomial is a polynomial with 3 terms, okay? Now, all trinomials take the form of ax squared plus bx plus c, okay? Well, not all, but typically this is your standard form for a trinomial, where a is some coefficient and b is some coefficient, and each of them are multiplied by their variables with the order, okay? Like I said, not all trinomials have to look like this, but this is your standard trinomial. So a simple trinomial is a polynomial in the form ax squared plus bx plus c, which we see here, but a is equal to 1. Well, if a is equal to 1, that means it's 1 times x squared. What does that actually mean? It means our simple trinomial looks like this. X squared plus bx plus c. Oh, so that means the coefficient in front of the x is just a 1. So the only real coefficient we have is the b term. And then we have our constant c, whatever that could be. Now, trinomials, they occur when we expand 2 binomials together, as we showed up here. We had x plus 8 times x plus 3, and we ended up with x squared plus 11x plus 24. Factoring is the opposite operation. So that's where we start with our trinomial, and we want to take it back to its two binomial forms. So to factor a simple trinomial, we're going to do a little trick. We're going to find 2 numbers. Let's call those numbers m and n. They don't have to be, those are just 2 arbitrary variables that we came up with, okay? We're going to call those 2 numbers m and n. Now these 2 numbers, they are going to add to the value b, and they're going to multiply to the value c. So we have to find 2 numbers that are true for both of these situations. They add to b, so m plus n is equal to b, and m times n is going to be equal to c. So we have to find 2 numbers that satisfy this. M plus n is equal to b, and m times n is equal to c. Then what we're going to do is we're going to create 2 sets of brackets, binomial, with the numbers found, and so x squared plus bx plus c. What we're going to do is we're going to take the x, so it's the square root of x squared. So we're going to take the x, and we're going to add on m. And then we're going to take the x, and we're going to add on n. And that's the process. So we will find 2 numbers that add to b and multiply to c. Okay, so let's try this out. Let's go down here, and we see x squared plus 11x plus 24. Now, for the first couple, I'm going to kind of spell it out, what we're actually trying to do here. Our b term, in this case, our b is equal to 11. And our c term is equal to 24. What this means is we need 2 numbers that add to 11 and multiply to 24. So we want two numbers that add to 11 and multiply to 24. So they need to add to 11 and they need to multiply to 24. Now, they can be any two numbers that satisfy this. So, you know, we know that they multiply to 24. So let's start with that. So let's think of all the numbers that multiply to 24. Well, there's 1 and 24. That doesn't add to 11. There's 2 and 12. That doesn't add to 11. There's 3 and 8. Ooh, 3 plus 8. Yes, that adds to 11. So if we think about it, we could say M, I'm going to make you 3. And N, I'm going to make you 8. So if we're following the form now we're going to say our solution here is x plus 8 multiplied by x plus 3. And we're done. Whoa, look at this. See the answer right here, x plus 8, x plus 3? We just reversed our example over here in A, x plus 8, x plus 3. Now, you're probably asking yourself, does it matter which order does it come in? M, N, what if M is 8 and N is 3? It will still work. You just might have to do an extra step sometimes to make that happen, but it will still work. It doesn't matter which order you actually choose them in. Mathematically, you're still good. So let's do another one over here. So in this case, we need to find two numbers that add to B. Well, B is a 1. There's that imaginary 1 that's sitting right there. So they add to 1, and they multiply to negative 12. Now we see something a little bit more interesting. We have to actually find it so the multiplier comes out to a negative 12. Now remember, when you're multiplying two numbers together, the only way you're going to get a negative result is if one and exactly one of those numbers is a negative. The other one's got to be a positive. So when we're coming up with numbers, we have to think about this. So we can't just go through 1, 12, 2, 6, and things like that, because when we multiply those, we're never going to get negative 12. It just doesn't work. So you have to go through all your multiples, but you also have to think about all of the positive and negative versions of those when we go through this. So 1 and 12, or negative 1, negative 12, those aren't going to work no matter what, because we're never going to get to a sum of 1 between the two values. What about 2 and 6? No, there's a difference of 4 there, so that's never going to work out. How about 3 and 4? There is a difference of 1 between 3 and 4, so that may actually work. So it needs to end up as a positive 1. So if I'm using 3 and 4, which one of these should be positive and which one should be negative? Well, in this case, since I want a positive sum, that means the bigger number should be positive. So in this case, I'm going to say 4 and negative 3. So there's our M and there's our N. Again, it doesn't really matter which one we use. We can choose whatever we want. So let's switch it up this time. I'll make N the negative 3 and I'll make M the 4. So our answer is A plus 4 bracket A minus 3. And there's our answer. If you were to multiply this out, you'd end up with A squared plus A minus 12. So again, the sign here that's next to our C is going to tell us whether we're dealing with opposite signs or the same signs. So if it's a negative, exactly one of our numbers needs to be negative. If it's a positive sign, they either both need to be positive or both need to be negative. Because if you multiply two positives, you get a positive. If you multiply two negatives, you get a positive. Okay? So if it's negative, exactly one. And then when you're looking for your numbers, you also can look at your B value and say, okay, well, now I need to find numbers that are going to create a difference between each other, or a distance between each other, that is going to add up to this if they're opposing signs. Otherwise, they need to add up to that number. So it's going to take a little bit of trial and error. It's going to take a little bit of practice until you're comfortable with it. All right, let's go to the next one, because this one has extra variables. So remember the format, x squared plus bx plus c. So our variable is the x here, because that's what's sitting out here. So our x squared, that means the y is actually part of b. So in this case, I need two numbers that add to negative 7y. I need two numbers that add to negative 7y. And I need two numbers that multiply to negative 18y squared. Okay, now things are getting a little bit more interesting. So let's think about this. Let's work our way down. Well, 1 and 18, that's not going to give me a 7. Remember, this is a negative, so 1's going to be a positive and 1's going to be a negative. 1 and 18, no. 2 and 9, that's interesting. 2 and 9 might work. So if I use m to be, and we need m and n, right? So let's say m is, let's make m, this is coming out to negative 7. So that means my larger number needs to be the negative. So this is going to be negative 9, but the y needs to be included. And this one is going to be positive 2y. So now we just plug it in. So our final answer is going to be x minus 9y and x plus 2y. If you were to multiply that out, you should end up with exactly where we started. Yeah, that's good. So we go over to the next one, and this is just the same process. Rinse and repeat, rinse and repeat, rinse and repeat. I'm not going to talk my way through every single one, or we'll be here all day. So let's work our way through this. If you want, you can pause the video here and try and solve them on your own, get some practice, and then resume the video and see if you ended up with the same result. So in this case, I want two numbers that add to 15 and multiply to negative 34. With a little trial and error and a little thinking, I'm going to find out that my two numbers are 17 and negative 2. 17 times 2 gives me 34, but I need it to be negative, so I made the negative 2, or the 2 negative. So now I have x plus 17, and I have x minus 2. And that's the whole thing. Let's go on to the next one. Ooh, this one's a little bit more interesting. Now we have x to the fourth minus 7x squared plus 10. So what is our a and what is our b? Well, not our b, not our a and b, our b and our c. So in this case, we need two numbers that add to negative 7. And they multiply to 10. Now that's a pretty quick and easy one because we can see 5 and 2 are the obvious ones here. So since this is a plus sign, they both need to have the same sign. So they're either both going to be positive or they're both going to be negative. Well, since this is a negative, that tells me that they're both going to be negative. So that means my m is going to be, I don't know, let's just choose, let's m be negative 5 and n be negative 2. Now, what am I writing here? I can't write x because this is x to the power of 4. It's actually the square root of this. So it's x squared. X squared minus 5. And then the next one is going to be x squared minus 2. Multiply that out, you're going to end up with what we started with again. Okay, let's go to the next one. Here we have x squared minus x minus 90. Well, that's a big number for c. So this is going to put us through our paces a little bit, so we have to think about it. So we have plus, what are they going to add to? They're going to add to negative 1. They're going to multiply to negative 90. Negative 90. Okay, so since that's a negative sign, that tells me that I'm going to have one positive and one negative. Okay? Now, since this is a negative sign, I know the bigger of my two numbers is going to be the negative, and the smaller of my two numbers is going to be the positive. So what are the obvious ones here? We got to get up to 90, and we need something with a difference of 1 approximately. So that means the obvious answer is 10 and 9. Now, since the result is negative for the sum, that means my bigger number is going to be the negative number here. So write it out. X minus 10 and x plus 9. There we go. And that's it so far. Let's go down to the next piece. Whoo-hoo! Again, what is our dominant variable here? We look at our equation, x squared plus bx plus c. The dominant variable is the a squared here. So the a squared, because we also see the a here. Technically speaking, the b could work just as well, but actually, yeah, it could work just as well, so it's going to be the same thing. Okay, so we need two numbers that add to what? They need to add to negative 5. They need to multiply to 4. This is a positive number, so that tells me that they're going to both be the same sign. This is a negative number, that tells me that they're both going to be negatives. Okay, so let's think of the numbers. What multiplies to 4? 1 and 4. Oh, those add to 5. That works out. So we found that one really, really quickly. So that means that our numbers are going to be -1 and -4. So we take the square root of the first term, and that is going to be our starting value in each one. So this is a, b. And we're going to subtract 1, and ab, subtract 4. That's supposed to be an a. There we go. And that's our answer. It looks more complicated, it is. The trickiest part is just coming up with that m and n. So let's do it again. Ooh. So what are we looking at here? Well, in this circumstance, we have an entire group that is going to act as our x from our original equation here. So if this is a little more complicated than you really want to deal with, let's simplify it. So let's create a little let statement here. Let's say let x be b plus 7. Okay? We're going to say let x be b plus 7. So let's rewrite the equation now. So now we have x squared plus 2 times x minus 15. Now let's factor this one. So we need two numbers that add to 2 and they multiply to -15. The 15 is negative, so I know I'm going to have one positive and one negative. The middle term is positive, so that means my bigger term is going to be the positive term. Okay, so 1 and 15, that doesn't work. 2 and nothing, 3 and 5. 3 and 5 will work. Yep, 3 and 5 will work just fine. So our bigger number is going to be the positive, so that means I'm going to have -3 and +5. Alrighty, so let's write that out. So that means I have x minus 3 times x minus 5. Or sorry, plus 5. But am I done? No, because I have to bring it back to the original equation. So now what we're going to do is we're going to sub our b plus 7 back into the equation. So let's say sub b plus 7 back in. Because we have to answer the original problem, not some new problem that we made up. So that means that we're going to have a bracket. Wherever we see an x, we're going to put a b plus 7. b plus 7 minus 3. And then on the next set of brackets, it's going to be b plus 7 plus 5. Okay, now let's simplify. B plus 7 minus 3, that's the same as B plus 4. Okay, and then over here we have B plus 7 plus 5, that's B plus 12. And there we go. We've solved the problem. Just because it looks challenging doesn't mean it's as challenging as you think it is. So try and simplify your work as much as you possibly can. So this is the basics of factoring in simple trinomials, but we're not quite done yet. All right, now we may run into some problems where it's not obvious or we can't find two numbers that work out. As always, and this is always your first step, you saw the flowchart from the first day, the first step is always to look for a greatest common factor. So even before you do any other work, always I want you to look for that greatest common factor, or the GCF. So simplify it by doing this and reducing our work. So in the first one, over here, we can see that each one of these terms can be divided by 4. No variables, but I do have a greatest common factor of 4. So I can take that out first. So let's do that. So equals 4, and then we divide 4 out of each term. So we have x squared plus 3x plus 2. Now we're going to factor the stuff inside. Okay? So we need to find two numbers that add to 3 and multiply to 2. This is a positive, so I'm going to have two of the same sign. This is a positive, so they're both going to be positive numbers. So what are the numbers? 1 and 2? Yep, makes sense. 2 plus 1 is 3. 2 times 1 is 2. So we leave the 4 alone. 4 isn't part of this. And we rewrite it. We have x. What did we come up with? We come up with 1 and 2, right? So x plus 1 times x plus 2. And we're done. That 4 just kind of sits on the outside. If you foiled these out and then multiplied that result by 4, you'd end up back where we started. Let's go to the next one. Exact same question, just simplify it first. What is our common factor? The only thing we have here is a 3. So we're going to take that out, so we end up with d squared minus 6d and plus 24. Oh, not plus 24, plus 8. Got ahead of myself there. I'm going to fix that d as well. There we go. Minus 6d plus 8. Okay, so now we need two numbers that multiply or to add to negative 6, and they multiply to positive 8. This is a positive number. They're both going to be the same sign. This is negative, which means they're both going to be negative. Okay, so 1 and 8, nope, that's not going to do it. 2 and 4, yep, 2 and 4 works. And since they're both going to be negative, I know I have negative 2 and negative 4. So we go down here, we got 3, and now we're going to say, well, it's going to be d, that's our square root of our first term, minus 2, and d minus 4. And there we go. Let's keep going. Now we're on to the next problem. What can we factor out? No variables, but we can factor out negative 5. So let's do that. Let's try and get rid of some negative signs here. Negative 5. As we do this, this just becomes x squared. Now, 40 divided by negative 5, that means the sign's going to flip. So this is going to be negative 8x. And negative divided by negative is a positive. So 60 divided by negative 5 is going to give us 12. Okay, so what do we need? We need two numbers that add to negative 8 and multiply to 12. Positives, they're both the same sign. Negative, they're both going to be negatives. Okay, so the obvious one here is, of course, what is the obvious one? I guess 6 and 2. Yeah, 6 and 2 makes sense. 2 times 6 is going to give us 12, and 2 plus 6 is going to give us 8. So they're both going to be negative. So negative 2 and negative 6. So let's write that out. We have negative 5 multiplied by the square root of our first term, which is x. Subtract 2, multiplied by x, subtract 6. Simple, easy peasy. Let's go to the next one. So, can we factor out anything here? Yep, we can factor out a 3 from each term. So this becomes a squared plus 2a minus 3. So we want two numbers that add to 2 and multiply to negative 3. This is a negative, so that means they're going to be opposite signs, and my bigger of the two is going to be positive. So what numbers multiply to 3 and add to 2? 1 and 3 makes the most sense. So 1 comma 3, and my biggest number is going to be my positive sign. Yes, my biggest one's going to be positive, so it means my smaller one's going to be negative. There we go. Now we fill it out. 3, square root of the first term, that's a minus 1. And then, oops, that should not be a comma, and then a minus 3. There we go. Or sorry, plus 3. Plus 3. We're almost there. I know this takes a lot. And as I said before in the very beginning of this unit, it's all about repetition. Practice, 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 practice. Please don't stop and do more until you're sick of it. Okay, in this case, what can we take out? The only thing we can really take out here is the 2. So let's take it out. So we have 2. And then we're going to end up with y squared minus 6y plus 9. All right, so we need two numbers that add to negative 6, and they multiply to 9. So the 9 is positive, which means they're both going to be the same sign. The negative 6 is a negative, so that means they're both going to be negative values. 1 and 9, no. That doesn't really work at all. 2 doesn't have a multiplier. 3. Oh, 3 and 3. 3 and 3 add to 6, and 3 times 3 is 9. So we're going to end up with negative 3 and negative 3. Okay. So that means we have 2 times square root of the first term, which is y, minus 3, and y minus 3. Now these brackets are the same, so we can simplify this a little bit further, and we could say 2 times y minus 3 squared. All right, last one here. So what do we have? We have a common greatest common factor of 5, but we also can get rid of a q. There's a q in each term. So we're going to factor out a 5q in this case. So this one's just going to become q squared on the inside. And then we're going to have minus 10q. And then 80 divided by 5 is 16. And the q goes away. So now we need two numbers that add to negative 10 and they multiply to 16. Now this is positive, which means they're both going to be the same sign, and the 10 is negative, so which means they're both going to be negatives. Okay, so let's see. 1 and 16? No. 2 and 8? 2 and 8? Does that work? Yeah. 2 plus 8 is 10, and 2 times 8 is 16. So we're going to write our 2 and 8. Now, both the same sign, and both negatives. There we go. Now we write it out. 5q, and then the next one here is our square root of our first term, which is q, and then minus 2, and q minus 8. Okay, hopefully everybody's getting a little bit more comfortable with this as we go. Next question is more of a thinking question. Explain two reasons why the expression x squared plus 3x plus 5 cannot be factored. Well, what's the first step whenever we want to factor? Trying to find a greatest common factor. There is no greatest common factor, so that eliminates that ability. Okay, so there's one good reason. There is no GCF. Okay, what else? This is a simple trinomial. We know how to solve a simple trinomial. We have to find two numbers that add to b, which is 3, and multiply to 5. Unfortunately, there are not two numbers that add to 3 and multiply to 5. There's no combination therein because 5 only has two multipliers, 1 and 5. And no matter what combination of signs you use there, you're never going to get to a 3. So that's another reason why this cannot be factored. So no two numbers add to 3 and multiply to 5. Whoa. Whoa. Am I writing a text here? What's going on here? Multiply to 5. Let's just pretend nobody saw that. Okay, one last little piece to the puzzle here. Example number 4. Find 3 different possible values for b so that the expression x squared plus bx plus 24 can be factored. Now, this again is a question on, it's kind of a somewhere in between a knowledge and a thinking question where you have to understand the rules to actually factor this simple trinomial in order to answer this. But you have to be clever enough to understand what is possible. So what are we looking for? We know that to factor this, because it's a simple trinomial, we have to have two numbers that multiply to 24. Okay, so we need two numbers that multiply to 24. However, they also need to add to b. So that means that the sum of these two numbers is b. Okay. So what does that mean? It just means we need to come up with two numbers that multiply to 24 3 times because it's asking for 3 and figure out what their sum is. Those are our possible b values. So let's try a few examples. Now we won't do the obvious ones. We'll do a couple off the wall here. So the first one is 1 and 24. If we chose those two numbers, what is going to be the value of b? B is just the sum of them. So that means that b is going to be equal to 25. Okay, so let's say we chose, let's say 3 and 8. Does that work? Yeah. 3 times 8 is 24, so that means that b is going to be 11. Okay, let's go a little bit more off the wall. Let's try, we can look at the signs. This is positive, and this is positive. So that means that they're both going to be the same sign, and they both, this one's throwing us off a little bit because they could be anything. I'm going to show you why. In this case, let's choose negative 4 and negative 6. Yes, they both have to be the same sign, but we can't trust this because we don't know what b is. So what do those two add up to be? Negative 4 times negative 6 is indeed 24. So that's safe. But what's b going to be in this case? b is going to be negative 10. So these are the three possible answers we're looking for. So therefore, some, because there's more, some values of b are, let's see, 25, 11, and negative 10. And yes, there are definitely more. Okay, so this is how we factor simple trinomials. Next time we're going to get into complex trinomials.